Hello guys, how are you all doing? And welcome back to another video from me, Jalaj Aurora from BHM at GCSE Chem. And today we're doing section 1.4, C1.4, which is all about fractional distillation and paper chromatography. And these are two very useful, physical techniques to kind of know about as well. Very important actually. Before I make a start, I'd like to show you again, like I've shown you this in every video so far, and I'll keep showing you this just in case you want it. It's the GCSE Chemistry AQA revision guide, and it's the one from Caboodle. And I teach AQA GCSE Chemistry because that's the exam board I did, but most of the chemistry is pretty much relevant to all exam boards, but there are subtle differences, and you'll need to check your spec for the differences, because there might be things that AQA needs to know but Edexcel doesn't, and vice versa, or maybe OCR as well. All the exam boards you're doing, there might be differences, but most of the chemistry stays the same, so make sure to check your spec. But I'll be teaching from AQA because that's the exam board that I did. But today we're doing C1.4, as I mentioned before. And it's all about fractional distillation and paper chromatography. So fractional distillation is a way to separate mixtures of miscible liquids. So miscible liquids are just liquids that are mixed together, and they don't form separate layers. That's the thing. So for example, ethanol and water, they're miscible liquids. Now miscible liquids dissolve in each other, mixing completely. So miscible liquids, they mix completely together, and they dissolve in each other, like ethanol and water, and they do not form separate layers. Now the liquids have different boiling points, and the liquid with the lowest boiling point is collected first. Now that's a very, very important point. With fractional distillation, what you have is you have liquids which have different boiling points, and you separate them from, you first kind of collect the liquid which has the lowest boiling point. You do distillation, fractional distillation on that, and then you basically do it on the other ones. Do the process on the other ones. To aid separation, you add a fractionating column. You can add a fractionating column to the distillation apparatus, whatever you say. Now, fractional distillation is a way to separate ethanol from a fermented mixture in the alcohol drinks industry. So it's basically a way of separating ethanol from a fermented mixture in the alcohols industry, as I said before. So it's very, very useful, and fractional distillation is actually also used in the separation of crude oil. So your crude oil can be separated into different fractions, and that you use fractional distillation to do that. And so, for example, here it says in fractional distillation, so this is a question, in fractional distillation, which liquid is collected first? Well, it's the liquid with the lowest boiling point. So for example, if it was ethanol and water has a boiling point of 100 degrees Celsius, ethanol has a boiling point of 78 degrees Celsius. So first ethanol will kind of go up the fractionating column, then it will go into the condenser, and then it will be collected. Then the same process will happen to the water, and you would have pure ethanol and pure water. So you'd have the pure solvents. So basically, this just shows here, this just shows kind of the apparatus, or apparatus, as I said, you can say it either way, for fractional distillation. So you basically have you have heat being supplied to a, let's say, what is it? It's just heat supplied to a tripod, and there's a tripod there. Heat supplied to the tripod. There's this flask here, and then you have a fractionating column. And basically, the liquids go up the fractionating column, and because they're heated, they now become they're heated, so they vaporize, and then they go through the condenser. Now the condenser is water, which just circulates around, which just makes sure that the vapor that is formed of these liquids, they then condense back into the liquid, so then they can be collected in a beaker. So for example, if it was ethanol and water, this process would first happen to ethanol it would be collected in a beaker, like it would be heated, it would go through the condenser and then be collected, and then the same process would happen to water. Now, why does it happen to ethanol first and then water? Because ethanol has a boiling point of, I believe it's 78 degrees Celsius, and water, it's 100 degrees Celsius. So first it'll be ethanol and then it'll be water. So, yep, so that's interesting. So that's fractional distillation. And also, I would recommend, by the way, if you're using the student book, it's pages 10 to 11. And I would recommend looking at the student book just in case, you don't really know much about this process, because basically this revision guide is just for a brief explanation, and it assumes that you already know kind of what the process of fractional distillation and paper chromatography and all the other things, you already know the content. That's what this book is all about. Once you've done the content, it's just kind of, if you're near exam time, it's just kind of a quick 120 pages brief explanation, but still very important, of each kind of topic. And that's why I don't use the big book, although, because I assume that you've already done this content. It's just to revise the kind of basics of like what is fractional distillation, what it's all about, what apparatus is used. And you could be asked in the exam to actually describe how fractional distillation works. So, for example, ethanol and water, or something else. Basically, depends on what they give you. Now, paper chromatography. Now we're going on to paper chromatography. That's a way to separate substances from mixtures in a solution. Now, you can separate substances from mixtures in a solution using paper chromatography. It works because some compounds are more soluble than others in the solvent. Because not all substances, not all compounds will be soluble in a solvent. For example, not everything is soluble in water. Water is a solvent. Like salt is soluble in water. Salt dissolves in water. But sand is insoluble in water. Sand does not dissolve in water. So not everything dissolves in a particular solvent. Not all compounds. So basically, it can help us separate substances from mixtures, in a solution. Basically, paper chromatography is a good way, that you can use, is a way to separate food colorings. And there is actually a process on, I'm not going to go through the actual process. If you want to go through, you can just, go through the student book. But basically, this is just a technique that you can use as well. And it's used, for example, to separate food colorings. So name the method. So name a method used to separate food dyes. So we've seen that food colorings is paper chromatography, and food dyes is also, you can use paper chromatography as well for that. And and this here the diagram I showed you, that fractional distillation one, very important to not learn it. They won't ask you to really draw it, but you just need to know what's going on. And so it just says fractional distillation of the miscible liquids, ethanol and water. Oh, sorry about the phone there. No noise from the phone, but so we said we did the second question, and just to finish off with the key points. Before that, keyword is chromatography, but also I'd say fractional distillation is also a very big keyword. Very important to understand what that is. Now, the main difference between fractional distillation and simple distillation, for example, you're just separating seawater. You're just obtaining, for example, here it's in 1.3, your seawater is distilled to obtain usable water. Here, in simple distillation, you don't have things like miscible liquids, but in fractional distillation, you have miscible liquids, which would have different boiling points, and then you separate them in the order of their boiling points, ascending boiling points. So you start from the lowest boiling point, then the next, then the higher, like the one after that, then the one after that, and eventually the liquid with the highest boiling point will be separated last. So that's basically the process, and that's basically the difference between simple distillation and fractional distillation. And in fractional distillation, you have a fractionating column, or you use a fractionating column. Now, synoptic link here, it says topic 9.2, C9.2 shows how fractional distillation finds use in separation of crude oil. As I said, crude oil can be separated into its fractions using fractional distillation. and you can see how paper chromatography, how to use paper chromatography to identify substances in C12.2. So obviously I didn't talk much about chromatography here, paper chromatography, because it is going to come up later, very later on. I mean, we're only on chapter 1 at the moment, but in C12.2 we're going to learn more about paper chromatography. But the key points, just to finish off, so the fractional distillation is an effective way of separating miscible liquids using a fractionating column. This word miscible liquids is very important because it's the reason why fractional distillation and simple distillation aren't the same. There's a clear difference between fractional distillation and simple distillation. Fractional distillation is used to separate miscible liquids. Very important. And the spelling on miscible liquids, miscible, is also very important. It's MISCIBLE. Very important to get that right. And we can use a fractionating column. The separation is possible because of the different boiling points of liquids in the mixture. Sorry for the noise there, but because of the different boiling points, as I said, this fractional distillation is just heavily relies on the different boiling points and the miscible liquid stuff. That's basically it. And then paper chromatography separates mixtures of substances dissolved in a solvent. So as they move up a piece of chromatography paper. So basically, when you conduct your chromatography experiment, you find that the mixtures of the substances, they kind of move up the paper, and the different substances are separated because they're different solubilities in the solvent. So you can separate them based on their solubilities in a particular solvent, because obviously, as I said before, not everything is soluble. Not all substances are soluble in a particular solvent. Different substances are soluble in different solvents. So that's basically it. So that's the end of this section, C1.4, fractional distillation and paper chromatography. I really hope it was useful. And now, after this, we're halfway through chapter 1. So we finished C1.4. I believe it's till 1.8. So we're halfway through. So that's good. So I'll be back with another video for tomorrow, which is on C1.5, history of the atom. Make sure to share, like, and subscribe, and I'll see you in the next video. Thank you very much, guys.